Hi, and welcome to our presentation. In the next little while, we will be talking to you about the Model Bridge competition for Newfoundland and Labrador. We will discuss the sorts of prizes you can win, the rules for each contest, and even some tips for building your bridge. The Model Bridge Building Competition is an activity developed for National Engineering and Geoscience Month. It is a chance to celebrate the techie and scientist in all of us, and to promote the work of engineers and geoscientists in Newfoundland and Labrador. In Newfoundland and Labrador, we hold two bridge building competitions, one for grades 7, 8, and 9, and one for grades 10, 11, and 12. We also hold a poster making contest and word search contest for students in younger grades. The competitions are open to students from all over the province, with bridge testing being carried out in the cities and towns shown here. Prizes for the Model Bridge competitions will be awarded at both the district and provincial level, with prizes being awarded for individual submissions as well as school submissions. See the complete rules on our website for a more detailed breakdown of prize distribution. This year, in addition to the normal prizes, high school students can even win a $1,000 MUN tuition voucher. This will be awarded based on an extra technical submission, the complete rules for which can be found on our website. The bridge competition rules are broken up as follows: bridge dimensions, the materials you can use, judges, and bridge scoring. You can download the complete rules at www.modelbridgesnl.ca. The critical dimensions for your bridge are as shown here. The bridge must be a minimum of 70 centimeters wide so that it will sit correctly on the test frame. It must be a maximum of 30 centimeters high. This is so that it will fit underneath the piston. If the deck of your bridge is at the bottom instead of the top, you must include a minimum 12 centimeter opening so that the ram may access the deck. If we cannot place the ram on your bridge deck, we may not be able to test the bridge. The only materials you may use to construct your bridge are standard wooden popsicle sticks, no large tongue depressors allowed, and white school glue. Both of these materials can be easily found at your local grocery store, department store, or hobby shop. Bridge scoring for the grades 7, 8, and 9 competition will consist of the following: a 30% judges evaluation based on quality of construction, that is, how well the bridge is built, and application of engineering principles, that is, how well the bridge is designed. And a 70% strength factor. This will be discussed shortly. For the high school competition, scoring will be broken up as follows. For those who wish to only submit a bridge, the scoring will consist of a strength factor plus bonus points. For those who wish to compete for the MUN tuition voucher, scoring will consist of a 90% strength factor plus a 10% submittal score plus bonus points. Strength factor for bridge scoring will be calculated as follows: the maximum load that the bridge will allow in the test frame divided by the mass of the bridge. A minimum weight of 100 grams will be assigned to each bridge. Bonus points for bridge scoring will be calculated as follows: for every 5 grams of bridge weight less than 600 grams, 1 bonus point will be added to the total strength factor, to a maximum of 125. That is, if your bridge weighs 595 grams, you get 1 bonus point. 590 grams, 2 bonus points, etc. When constructing your model bridge, there are a few things to keep in mind, such as the distance your bridge will need to span, the type of bridge you're going to build, how you're going to go about constructing the bridge, and the quality of materials you're going to construct it out of. When designing your bridge, try and keep a few of the following points in mind. How far your bridge is going to have to span, in this case a minimum of 70 centimeters. The basic dimensions of the popsicle stick when laying out members. How the piston force applied by the test frame is going to be transferred through each member to the supports. And finally, keep in mind the weight formula or strength factor. This is calculated as the maximum load a bridge can take divided by the bridge's mass. Therefore, a lighter bridge that can take a heavier weight will score a higher strength factor. When coming up with a design for your bridge, Keep in mind that there are many different types of bridges. Some are beam, truss, cable, and suspension. Beam bridges consist of horizontal beams supported at their ends by abutments. The bridge deck is then supported on top of these beams. A beam bridge can be something as simple as a wooden log laid across a stream, or as sophisticated as reinforced concrete and steel spanning a river. Truss bridges are similar to beam bridges in that they are supported at their ends by abutments. Rather than large, heavy elements spanning from one end of the bridge to the other, truss bridges are composed of smaller, lighter elements that may be stressed in either tension or compression to carry the loads. This makes for a more economic use of materials, allowing the truss bridge to span greater distances. Suspension bridges have cables strung over the top of large towers and anchored at each end. Smaller cables, known as hangers, are attached to these main cables and support the bridge deck below. Cable bridges are similar to suspension bridges in that the bridge deck is supported from above, not below, but with a cable bridge, the hangers are connected directly to the large towers instead of the main cables. When you've completed all your research and have an idea of what type of bridge it is you want to build, it's time to get down to business. But remember, safety first. Always wear safety glasses when cutting and trimming popsicle sticks, or have an adult help you with it. We have to say that. When you finally sit down to begin building your bridge, remember, take time to plan and prepare your design. Make a drawing on paper and make some notes if you have to. At this point, a good idea is to remember to reinforce the deck of your bridge to prevent the ram from punching through. Take some time to sort through the popsicle sticks in the box you bought. Remove any sticks that are twisted or cracked. Remember, you only want to use the best sticks for your bridge. Before you start gluing anything, make sure the popsicle sticks are clean and dry. Wet or dirty sticks won't hold the glue properly. Cut and trim the sticks as necessary to conform to your design. Remember, wear safety glasses. No one wants a popsicle stick in the eye. For better results, you might want to consider clamping the joints of your bridge together while the glue dries, for a minimum of 24 hours. This will ensure a stronger joint. When you're finished with all your hard work, it'll be time to test your bridge by smashing it at Bridge Day. To give you an idea of how this will all take place on Bridge Day, we've prepared the following video. On Bridge Day, your model bridge will be tested using the equipment shown here. After you have registered, a number will be assigned to your bridge and it will be weighed. Before it is tested, this information will be entered into the test frame computer. When it's time for your bridge to be tested, one of the Bridge Day volunteers will carefully position your bridge on the test frame, with the middle centered below the piston. Next, they will check the force gauge to ensure it is at 0. When everything is ready, they will begin applying weight to the bridge using the hydraulic pump. As weight is applied to the bridge, it is monitored by the test frame computer until the bridge fails. To demonstrate this process, we had 2 Bridge Day volunteers make bridges of their own, Sarah and Alex. Sarah started her bridge 2 weeks ago. She drew up a plan on paper, used only the best sticks from the box, and completed her bridge with plenty of time for the glue to dry. As you can see, Sarah's bridge is solidly constructed. It is well thought out, has bracing going in both directions, and all joints are solidly glued together. Alex, on the other hand, started his bridge last night. He didn't have much of a plan in mind. He used whatever sticks were on the top of the box, and he glued the last sticks to the bridge in the car on the way over. While Alex's bridge looks pretty good, it isn't well laid out. The joints are not glued together at the bottom, and the deck is not reinforced where the piston will bear. First up, We'll see how much weight Sarah's bridge can handle. "131 kilograms. Not too shabby, Sarah." Now let's see how Alex's bridge shapes up. Only 32 kilograms. That won't be enough to beat Sarah today. Looks like we have a winner. Better luck next year, Alex. Hopefully the information in this presentation is enough to get you started on designing and building your own bridge. If you require more information, you might find them at these helpful and interesting links. Thank you for watching our presentation. If you have any questions concerning the model bridge building competition, you may be able to find the answers at www.modelbridgesnl.ca. With that said, we're looking forward to seeing you and your bridge at Bridge Day this year. Until then, happy bridge building.